All right, guys, we're going to finish off chapter 3, discussing conditional probability and probability that involves our multiplication rule. So once again, a lot of this we'll do in class through examples, but I want to make sure that you get some of the notes and some of the rules down ahead of time. So, first thing, when we are trying to find the probability that one event will happen under the condition that some other event is already known to have occurred, we are trying to find a conditional probability. So these are going to be questions such as, given that somebody is a female, what is the probability that they have blue eyes? Okay, we're putting that known event having already occurred. Given that this has happened, what is the probability of something else happening? Okay, that's what we refer to as a conditional probability. So suppose we know that event A has happened, then the probability that event B happens, given that event A has happened, is denoted by the symbolic notation P, probability of B given A. That line represents the word given, okay? So when you see P and then in parentheses B with the line A, that means the probability of B happening given that A has already happened. So this could be something like the probability of being or having blue eyes given that somebody is a female. The order matters because the probability of blue eyes given female is not the same as the probability of female given blue eyes. Okay, so it's important that you get the order down when we're discussing these types of probabilities. So, our conditional probability formula, which is on the formula sheet, looks like this. If we've got the probability of A given B, it's equal to the probability of A and B over the probability of B. And if we reverse that, and then we do the probability of B given A, that's equal to the probability of B and A over the probability of A. So your denominator is your overall total, okay? So the second event is the condition, and that first event is what we use as our numerator. So if we want to know what's the probability of blue eyes given female, my numerator would be blue eyes and female, and my denominator would just be all of the females, whatever that percentage is or that total number is. The general multiplication rule is especially useful when a chance process involves a sequence of events. So when we have a sequence of events occurring, we use our multiplication rule. If we want to know what's the probability of this happening and this, when you have that word and with probability, that represents multiplication. The word or represented addition. The word and represents multiplication. So when we do that, we can create a tree diagram. And we're going to see multiple examples here where we're creating tree diagrams during class. Okay, we'll take a look at those examples, as well as example 4 in class. So, just some questions that we can answer though. What is the general multiplication rule? So your general multiplication rule, the probability of A and B, remember, that represents the word and, it's our intersection symbol, is equal to the probability of A times the probability of B given A. And this formula is sort of on the formula sheet, just written as your conditional probability formula, which looks like this. The probability of B given A is equal to the probability of A and B over the probability of A. So you'll see it on the formula sheet in this form, but it's just the same exact formula, just solved for different things. Okay, so we know it's the same formula expressed differently. You must show all work on the AP exam and all calculations, even if they're as simple as it might be. You have to show it. So don't just give an answer of a decimal. So we either can give a fraction answer or the decimal with the fraction. Decimal only is no good. Okay? Do not just do that. We use a tree diagram for a sequence of events occurring. So say we're doing a problem and we say, what's the probability that they're going to win the game, or that they score 8 runs and they win the game? I could use a tree diagram to do that. I could draw out, okay, here's my team. First, the probability that they're going to score 8 runs or not score 8 runs, and then a win or a loss. When it's a sequence of events occurring, then we could use a tree diagram to find those probabilities out. So what does it mean for two events to be independent? Okay? Independent events means that the knowledge about one event occurring gives no information about the other event occurring. So when you have independent events, one event does not impact the second event. So for example, flipping a coin are independent events. Just because I got heads on the first flip, that has no impact of what's happening on the second event there. So those events would be considered independent events. Two events are independent if the occurrence of one event, like we just said, does not change the probability of the second event occurring. So how do we prove if two events are independent? And this is a question that's appeared lots of times on AP exams. Are the event being a male and having blue eyes independent? Well, in order to determine that, we have to check, is the probability of A given B equal to the probability of A? And is the probability of B given A equal to the probability of B? If these two things are true, then the events are independent. Okay? Why? Well, let's see what this formula says. Is the probability of A given B equal to the probability of A? So if we here, the left side here is talking about a conditional probability, meaning knowing event B has occurred, does that affect the overall probability? If it doesn't, then the events are independent. Okay? If it does, then the events are not independent. So both of these things must be true in order to determine if two events are independent. So in the event that your events are independent, you've proven independence by checking the formula that's right there, then you do have a separate multiplication rule for independent events, which means that you can just multiply those two probabilities together. The probability of A and B is equal to the probability of A times the probability of B. This is the multiplication rule for independent events only. Notice that it's slightly different than our other multiplication rule that we saw, which is the probability of B given A as the second part of that formula. We're going to be doing lots of examples in class related to this. Okay, the more you practice with probability, the better you'll get. I'll see you in class.